What's up, guys? Let's take a look at day 6 of Advent of Code. This one's called Guard Gallivant. We've got a lab patrolled by a guard who, starting here in this example, follows 2 rules. If the spot in front of us is empty, represented by a dot, we take it. We walk forward 1. If the spot in front of us is obstructed, represented by a hash, we turn 90 degrees to the right, and that's it. You can imagine once we set this off, we go forward, turn, right, turn, down, turn, left, etc. until it ends when we walk off screen, off grid, and we're done. You might also ask, what if we get stuck in a loop? Well, that's what part 2 is about. So in this example, our little guard goes 41 times until finally escaping. Let's see the code, which I've got written out. You're not going to hear the clickety-clack of me typing, but you will hear me explain, especially when it gets good in part 2. The first thing I did when coding was copy my lookup of the grid from, I think it was day 4, because it was great, it was useful. I've got a tuple of row and column, or you can call it X and Y, whatever, to the character at that point, because this is a string just like it was a few days ago. And then I've got my types, point, and I call this space, but you could call it grid, you could call it something else. So we read the file, nothing fancy, and I hard-coded the starting position just to avoid a little double loop every time. Then we read the lines, nothing to worry about with the parsing, and we start looking into part 1. I've got a function called patrol, which I originally just called part 1, but we're going to end up using it for both, and let's see what it does. We've got a while loop, and we've got position for our row and column. We've got, I called it slope, which is also fine if you call it direction or something else, and it's your 1, -1, 0 in any particular angle. And then I've got ahead, which is like our next spot. I wanted to use the word next, but that's a keyword in Python. It's a pretty good function, actually. Now, we use the get method on our lookup. I still don't have it as a default dict, but maybe I'll change that eventually. I'm totally comfortable with get. And so if we have a dot, we move ahead. The first time I tried this, I got stuck in the middle, and I realized, oh yeah, we can also walk over our starting spot, which we don't change. We don't like overwrite it and actually move the arrow around. We just stay with that. And then we say, okay, position is now ahead, which was the next spot, and we got to add it to this visited thing. Originally, I had that as just a set of spots where we've been, set of positions, and that worked fine, but of course it'll get complicated in part 2. So then if we hit a table or a desk or whatever's obstructing us, we turn right, which is this little twisty thing, because you're always going to be 0 in one respect, either horizontal or vertical, and then you're going to be 1 in the other, showing all 4 possibilities. And then we've got, what if we hit none from the get, which means we've gone off screen? Well, then we return all the spaces we visited. So part 1 is to just do that and find the length, because it asks how many. So if we run that, we get, I think it was 41 for part 1. Great. However, part 2 is when it gets good, and part 2 says, okay, what if we're trying to make the guard stuck in a loop? We have one obstacle, one little box that we can put down, and if that turns the guard in such a way that it'll get stuck in a little rectangle or something, or it could be a more complicated loop, then we've succeeded. We've taken that guard out of commission so we can pull off our heist or whatever. So how do we do that? Well, let's just check every possibility. You could check, what if I put a hash on every spot in the grid, but we can narrow that down a little bit by just checking part 1. So if I sent the guard off and it went everywhere, I think she went everywhere is the pronoun they use, then those are the ones I have to check, because maybe the top left corner never gets visited, which means it's never going to matter for putting an obstacle down. So the first thing we do is we just check all the spots that we would have visited with no extra obstacles. And how do we do that? Well, let's talk about this visited thing, because like I said, originally I did just a set of points, but then we have an issue because I'm trying to get the same points in a loopy way. And we can hit the same points we've been before, like we talked about at the beginning. You can maybe go up from your starting point and then go right to it later. So the spot's not enough. We need the whole state of the guard, which is the spot and the direction. So I made the visited be point and slope. However, first I tried to make those together as a tuple. I was like, oh yeah, we just take point and slope, point and slope, point and slope. And that ruined part 1, because part 1 I was trying to take the length of the thing, but now we can say, oh, I've been to like 5, 5 going up, and I've been to 5, 5 going down, and that is counting twice when I really wanted to count it once for part 1. So what do you do if you've got these things and you want to keep track of them, but one of them is unique? Well, you use a dictionary. So the points are unique. We only go to a point once in the part 1 sense of the word. And then you can have a point and like, oh, here are all the ways that I've been to this point. Here are all the ways that I've been to this point, which is a dictionary, or in my case, a default dict, because you can just .add fearlessly without worrying about whether you have to start a blank one or something. I've talked about this before. I think default dicts are great for adding more than they are for looking things up. So like if you're going to make a list and then append, that's convenient. Whereas I'm totally fine looking things up with .get. In fact, I think it's kind of a nice reminder to say, hey, this is a, like an option, like it could be none. Whereas right here, this is convenient, purely convenient. Now, what if we go to a place we've been and in the same direction? Then it must be a loop. Like that's enough evidence. If I've been in a single spot, go in a single direction, and then 20 steps later I'm in that same spot, go in the same direction, that's enough for me to know it's a loop. I don't need any more evidence than that. So we kick out, we're done. I was really thinking about setting up a whole monad result thing where like you return okay visited but error loop. Instead, I just decided to cheat and say, hey, my type annotation, which I've been focusing on the last few days, my type annotation is now no longer fully explanatory about what the function does, because it could give you a visited or it could give you an error. So if we've gone to a place in a loopy way, we kick out with an error. I would definitely like to come back and make this prettier, but that was a good way to just cheat and get out of the whole cycle and say, nope, we're done. So how do we do that? Well, I use the classic try except. And this makes me a little annoyed because I have to do 0 plus 1. I can't use like a sum unless I extract this into another function. But I knew this was going to be a performance issue. Like, okay, we're doing try except, we're also making function calls, and we're also making a new dictionary every time. Oh my gosh. So what I did was to just say, instead of worrying about like, oh, our new obstacle, we're gonna like overwrite the original dictionary and then undo it later, or we're gonna add an if statement of like, oh, we pass in the obstacle, if you hit that, then that's special. Instead, we just make a new dictionary with the one spot that we've taken from the original patrol. That one spot is changed into a hash. So this is going to be slow, right? Because it's making a big dictionaries. And it's doing try except, and I'm already calling multiple functions. So I thought extracting that into another function to wrap the try and do it in a some consistent thing, maybe that'd be too much. So anyway, let's talk about part 2. When we run it on the test data, we get a 6, and that is what they say, right? But what does that mean? That means there are 6 possible spots where we could put a hash in a way that would result in a loop. So it's not like we just have to try one thing and see if it's a loop. It's we have to try every possible thing until it loops or until it escapes, which means we're checking a lot of stuff in a lot of ways and a lot of combos. And yes, this is going to be slow. Let's try it, see what happens. I think it's going to be like 15 seconds. Let's say run. Okay, part 1, no problem. Less than a second, 5176, fine. But remember, for part 2, it's checking that to get the setup of the candidates we're going to put down hashes. Then it's making a copy of the space every single time with just one change. All right, that wasn't too bad. I think it was probably 10 seconds or a little over. But, of course, we could try something else. What do we think about maybe getting rid of this part? Maybe I don't want to make a new dictionary every time. What if that's going to make a difference? Let's just try it just for fun. Let's say, okay, what if there's a function? Oh, you know what? This should probably be patrol, not part 1, because we don't need to do the len thing. Yeah, maybe that's a tiny performance improvement as well. So let's say, hey, I'm going to give you the obstacle. Instead of giving you a whole new dictionary with just one change, I'm just going to tell you that, like, hey, this spot is different. Okay? So what if this one can get a special thing, which is a point, but if you give it nothing, which is fine, and that's what we do in part 1, let's just say there's a -1, which is like not real, just as a default. I think the type would make me feel bad if I said equals none, because then it's like, well, it's a point, but also not a point most of the time. So now we could just say, okay, if ahead is not obstacle, else hash. Okay, so this is like, hey, we look up in the space, in the grid, unless it was this special case, and then, okay, fine, it's a hash. So is that going to be any better performance-wise since we're not making a new dictionary every time? Maybe. Let's run it. Okay, we got to 5176. Maybe if I talk by the end of the sentence, we'll get to 1686. And I'm guessing it's going to be about the same. You know, dictionaries are pretty good in Python. Making them is not that great. But okay, this could have even been worse. Maybe just the conditional every time ends up slowing it down. Or maybe the gains from not copying the dictionary are in memory use rather than time. So we could talk about that, and I definitely hate the ugliness of this line. So I'm going to Control Z to bring it back and make that function a little cleaner. Keep Control Zing. But actually this change was correct. I was trying to call part 1, but I really only need to call patrol, which is slightly more direct. And you can see that I'm not even doing anything with the function, right? I'm not assigning the result. I'm not having any side effects. I'm only checking to see if there's an error. So whatever. Anyway, that was a good one. I'm 1 day behind, so maybe I'll do day 7 today as well. Maybe not. We'll see. Thanks.